No one sets out to design an application that resembles this bowl of spaghetti, or at least I hope not. Despite our best intentions at the outset of a project, we sometimes find ourselves dealing with a tangled mess of software over time. We can all relate in some way to what I'm talking about. It's that behemoth codebase that painfully forces you to practically reverse engineer it just to find where that one line of code that needs changing is. And of course, all too often, changing that one line of code mysteriously ends up breaking 6 other things. We've all worked on monsters like this, right? So how does a beautifully architected application become the stuff of nightmares? Well, there are several contributing factors that can turn a masterpiece into a jumble of code. All but the most trivial projects end up representing months or years of effort, and in that time, teams usually evolve. New members join or work gets outsourced to contracted teams of developers, so it's not uncommon for these developers to be unfamiliar with the existing architecture and often end up deviating from the original vision. And it's not just the new people on the team. It doesn't take very long for our future selves to forget how everything fits together. And then, guess what? We also end up deviating from the original vision. This all too easily ends up with new features being added haphazardly, and then the inevitable happens. We end up with spaghetti. And what if the original designers leave the team? It's like losing the blueprint of the building you're constructing. Without their oversight, the application's design can become a mystery, leaving room for chaos and more spaghetti. Then there's time. In the real world, we are subject to time constraints. This often applies pressure on developers to resort to quick fixes or hacks. What starts as a temporary solution almost invariably morphs into a permanent scar on your application's architecture. I'm always interested in hearing people's horror stories, so let me know in the comments your worst experiences of this kind of thing. Enough of the problems, what about solutions? Code review is a common approach, but this requires your team members to not only spare some time for review, but to also be aware of the system architecture themselves, which, as we know, may not always be the case. I also feel that enforcing architecture through code review isn't a valuable use of either developer's time. Don't get me wrong, code review is a great way for developers to learn from one another, something there will be less time for if the reviewer is getting bogged down relaying architecture violations. You probably won't be surprised to hear that we can cover a great deal of ground by using code tooling and automation. Compile time enforcement takes us a surprisingly long way in itself. This is using code features such as setting access modifiers to control code use. For example, I like to take care to set my classes to internal, if not private. This means that they can only be accessed from within their assembly, unless I add this line to the CS proj file. This means you can specify exactly which assembly has access to what. I know many of you may be rolling your eyes thinking this is really basic stuff. I've seen firsthand many code bases where developers just use a blanket approach of setting every accessor to be public, rather than slowing down a little and thinking things through. Other examples of compile time directives are the use of custom attributes and applying code analysis tools. But again, this requires that design rules be in place and that developers have knowledge that they exist and should be adhered to. We need to get past this recurring hurdle. To do this, we have a third option: architecture tests. Think unit testing for your application architecture. You can use these tests to scrutinize the design, structure, and interactions of software components. For example, an architecture test can check that naming conventions are being adhered to, that dependency rules are followed, and that classes are in the correct namespace for their type. Architecture tests can really automate the enforcement of your architecture and coding design rules, freeing up time for everyone on the team without compromising the application. If you're listening to this and drawing parallels to linting, it's important to understand that architecture testing goes far beyond what traditional linters offer. Linters primarily focus on surface-level code quality, such as indentation, formatting, and variable naming. Whilst linters are incredibly useful for identifying such syntactical issues and maintaining containing coding standards, they fall short when it comes to revealing the intricate architectural flaws that can accumulate in a complex software system. Okay, so now we know the why, what about the how? I'm going to introduce you to two open source NuGet libraries used for writing architecture tests. Both are based on the Java library ArchUnit. Yes, I'm just trying to trigger you. I know it's ArchUnit. The first library, NetArchTest, has been created by developer Ben Morris. NetArchTest has over 1.2 million downloads on NuGet. It boasts a Fluent API and is compatible with both the legacy .NET Framework and .NET Core. Let's try it out in a sample application. I've built a standard 3-tiered application consisting of a data project, a service project, and an API project. In my sample project, the general rules that I'd like for us to test are 1. That entities have an appropriate accessor, which in this case means anything other than public. 2. That all repositories reside in the scoopsdata.repositories namespace. 3. That they inherit from the interface iRepository. And finally, 4. That the API layer should not be able to access the data layer directly. It must go through the service layer. In other words, we shouldn't be seeing any code that calls methods in the data layer from this API layer. So let's write some tests to describe this. I've added a fourth project using the NUnit template with references to my 3 application layers and installed the NuGet library NetArchTest.rules. Yes, I prefer NUnit over XUnit, and I fully realize that many of you will be disapproving of my choice. No, I do not want to debate it, but feel free to share your preferences and your reasoning in the comments. As I mentioned, NetArchTest uses a really cool Fluent API to articulate tests in a way that makes them far more human readable. Let's write a test. First, let's check that all the entities in the scoopsdata.entities namespace do not have a public accessor. To do this, we grab all the types in the data layer assembly, then filter that list down to only those that reside in the particular namespace we're interested in. Then we write a condition list where we state that the objects in the specified namespace should not be public. We can then call this getResult method, which is available on the condition list itself. Having created a result object, we can then assert if that result actually passes or not, just as you would with a regular unit test. If you haven't already heard of the popular NuGet library Fluent Assertions created by Dennis Duman, then you should definitely go check it out. You can blend Fluent Assertions right in with our other Fluent code here to further improve the readability of the code. Now we just need to write tests to cover the other rules we set out. Let's write a test that checks that only allowed namespaces can have a dependency on scoopsdata.repositories. The logic here is that we want to ensure that a repository can't be used directly in the API layer. To make this work, we need to filter the types that have a dependency on the top-level namespace scoopsdata, and then check that those dependencies reside somewhere in the service layer namespace, scoops services. This test fails, but I don't know why. Running it in debug, I have visibility of failing type names, and I can see that I also need to allow the types in the namespace to have a dependency upon themselves. I find this a little cumbersome. I don't want to have to run my test in debug to find out why a test is failing. I could probably write the test in such a way that it will spit the error out, but I shouldn't have to. All right, let's continue. I can also approach this architecture rule in a different way, as I have done here. I specify that any types that reside in the Scoops API's namespace should not have a dependency on anything in Scoops data. Is testing more or less the same thing, but having good test coverage by writing the same test in different ways is good practice. On the subject of good test coverage, one thing you need to be aware of when writing tests is how you could be missing some violations. In this library in particular, because of the way you filter to the types you want to test, it can be quite easy to miss a potential problem. Let me show you what I mean. Let's take this test where I filter the types down to those that reside in the scoopsdata.repositories namespace, and then check that they implement the interface iRepository and have a name ending with repository. Seems like a valid test, which of course it is. But what if a developer added a repository in a different namespace? We must also test for that possibility too. So in the next test, I need to write a different filter on the types, this time requesting a list of all the types that implement iRepository, and then subsequently check that they are in the correct namespace. Covering as many possible outcomes as we can think of is all part of writing extensive unit tests, which many of you will already be familiar with doing. The NetArchTest library does have a feature which can help you cover all these eventualities a little more cohesively. This is something called policies. A policy enables condition lists to be grouped together using a fluent interface. I really like this as it makes it easier to read the rules of the system. Let's explore them further. I've defined two policies. The first policy, called Data Layer Access Policy, covers the rules around accessing the data layer from other parts of the code. The second policy, Data Layer Policy, is concerned with rules that cover how the data layer is written and constructed. Let's take a closer look at the second data layer policy as it's more interesting. Inside each of these add method blocks, I have an expression that defines the condition list. This is basically the same as the condition list laid out in the discrete tests earlier. I need to give each condition list a name and a description. This makes it easier to see what each condition list is covering without having to read the code. However, to test these policies, we need to jump through a few hoops. There are example policies in the NetArchTest project repo. These examples show the policies being run in an executable rather than by the testing framework. They demonstrate code that iterates over each rule and prints any failures to the console. I'm not a fan of this way, as I much prefer to have tests listed out in the Test Explorer, which this approach doesn't do. So instead, I've adapted this into the environment that we'd expect these to be running in. I have implemented it using the test case feature of NUnit. To do this, I need to create an IEnumerable of policy definition, like this, and then add each policy. I can then pass the IEnumerable to the test case source attribute of this test, which when run will pass a single policy definition as an argument. I then evaluate the policy and iterate over the results. The benefit of this approach is that the Test Explorer will show a test per policy in the collection. However, it won't break down the individual results that we loop over, so it's not obvious which aspect of the policy fails. This really isn't ideal. I have to enter debug to delve deeper into the failure. This is the same problem we saw earlier with failing tests. I could probably fiddle with this further, but I just don't want to. And if I'm missing an easy fix to this, do let me know in the comments. That's a quick overview of NetArchTest. Time to check out the second library, ArchUnitNet. ArchUnitNet appears to be an official port of the Java library ArchUnit, which, if you recall, NetArchTest is also based on. ArchUnitNet also utilizes a Fluent API, and with some digging, I found it supports .NET Framework and .NET Core. It's worth noting that at the time of recording this video, the install instructions on the docs, GitHub README, and NuGet page are a bit out of date and need a bit of maintenance. The required fix is simple. The package name now needs to include the prefix TNG Tech, the project sponsor, so just pop that in front of any of the library names. And yes, it does have several libraries, each specific to your testing library of choice. Download numbers for the main library are over 1.1 million, the XUnit variant with nearly 700,000, NUnit with 335,000, and MS Test bringing up the year with just 27,000 downloads. Wait, does that mean, based on this metric, that NUnit is less popular than XUnit and I'm in the wrong camp? Whatever. Remember not to get drawn into arguments like this. Also, only the Sith deal in absolutes, and we're all in the green lightsaber club, are we not? I've created another NUnit test project, again with references to my application layers. So for me, I have installed the NUnit variant of ArchUnitNet. Comparing ArchUnitNet to NetArchTest, things are broadly similar, but there are plenty of differences in how we need to define things. Firstly, I need to declare all of the assemblies I wish to test against. This is known as the architecture. I do this once at the start of the test class. Next, I define specific items such as a layer, in this case the data layer, which is a collection of everything that resides in the Scoops data assembly. I can also define collections of classes like this one here, where I have every class that implements the iRepository interface. I can also further refine these collections as I have on this line, where I have everything that's available in the Scoops services assembly, which also resides within the Scoops services.services namespace. I can then use all of these predefined items in my tests. If you prefer, you have the option to define all these things, excluding the architecture, as and when you need them within each test. It's up to you really. Do whatever makes the most sense for you and your team. In my example, I'm going to test for the same things that we did in the other library. We'll be starting with the entities should not be public rule. I define an iArch rule called entity rule, and as you can see, the Fluent API makes this really easy. Classes that reside in namespace Scoops data.entities should not be public, and this optional method on the end because they should be private or internal. I really quite like the inclusion of this because method. Being able to articulate the reason why a rule has been included adds value to the design of the system and forms living documentation. Now, this next bit is a good example of how the two libraries differ somewhat. The first library, NetArchTest, returns a result that you can then append a Fluent assertion to, so it looks more like a regular unit test you may have in your project. ArchUnitNet, on the other hand, provides a check method on the rule, which is actually a wrapper for the NUnit method assert.fail. I assume it has similar wrappers in the other test libraries, but I haven't personally checked this out. This, in my opinion, keeps the tests concise and legible. I like it. You can also write this code as a one-liner, calling the check on the rule definition directly, like this. Just as before, one does need to put some thought into all the possible places where the design could be breached and write tests to cover those possibilities. Let's look at the test where we want to ensure that only the allowed namespaces can have a dependency on Scoops data.repositories. This test looks very similar to NetArchTest, only this time I don't have to explicitly include a reference to its own namespace. However, for this second test, where we check that the API layer doesn't have a dependency on the data layer, I can see a huge improvement in the way the test can be written. Instead of just looking at the namespace, I can define that anything in one assembly cannot depend on anything from another assembly. This is really powerful and makes it clearer to understand what the tests are trying to achieve. Okay, let's move on. What about combining different rules like the policies we saw in NetArchTest? ArchUnitNet doesn't literally have policies, but it does allow you to combine separate rules together into a combined single rule, and then test them all at once. Let's check it out. I've created a new test called repository rules. I've defined the items I'm using within the test method for simplicity, but you could still define them at a class level as before if you prefer. Next, I define all the rules that apply to the repository. These are basically all the rules we tested in the individual test methods earlier, but now they're all in one place. This makes understanding the big picture a lot easier, just as it did with policies in the other library. Finally, we can combine all the rules into the single combined rule using the AND method, chaining all the rules together. As before, we call the check method on this combined rule, passing in the architecture as usual. One pivotal difference between this library, ArchUnitNet, and NetArchTest relates to how error messages are reported. Let me show you what I mean. This set of rules has a failing test in it. In my code, I've made the mistake of giving my entities public accesses when I shouldn't have. Let's run the test and check out what that looks like in the Test Explorer. Look at this error message. Isn't it amazing? I love it. It's so informative. It's formatted the error message into a readable sentence based on the Fluent API, and I haven't had to do anything. Stuff like this really makes me smile. Good job, ArchUnitTest. Alright, we've checked out both libraries, but which one do I think you should use? Before I tell you, let me briefly summarize some of my thoughts. Neither library has great documentation, if I'm perfectly honest. ArchUnitTest may just have the edge. It has some diagrams with suggestions on what to test, whereas the documentation for NetArchTest is a blog post on the author's website. But we all should remind ourselves both libraries are free and open source. The fact that they have the documentation they have is great. Project maintainers work on these libraries in their own time, and let's be real, maintaining projects like these can all too often be a thankless effort. Documentation writing is hard and time-consuming at the best of times, so let's cut them some slack. If you find yourself using one of these libraries or any open source library, you could always give back to the community by making contributions to the project, and this could include their documentation. Alrighty, what else? Both libraries use a Fluent API to define their rules, which makes them really readable. This is particularly useful if you are co-developing rules alongside less code-savvy people, such as some QAs. I like how NetArchTest is in keeping with the standard unit test pattern of arrange, act, and assert. ArchUnitNet deviates from this convention by introducing a wrapper method, check, to instead execute the assert. However, this does mean you have the theoretical option to easily change the underlying test framework without having to rewrite your tests, just by updating to the relevant NuGet package. Whether this is genuinely an advantage or falls into a similar mindset of using a database abstraction layer just so you can change the underlying database provider, I'll leave that to you to decide. I really appreciated being able to write tests around assemblies using ArchUnitNet, and not just namespaces as provided in NetArchTest. But the real clincher was the error reporting when a test fails. NetArchTest doesn't measure up as strongly compared to ArchUnitNet, with the latter having an excellent, easy-to-use error reporting mechanism. This alone makes ArchUnitNet the better choice in my opinion. I also found the way of defining layers, collections of objects, and the overall architecture in ArchUnitNet more intuitive than NetArchTest. Regardless of which library you choose in the end, I think we can all agree that the addition of architecture tests is invaluable. It's a way of capturing the original vision of the system and enforcing it. As a reminder, enforcing architecture greatly aids in preventing code from descending into a tangled mess that's hard to maintain, hard to update, and just generally a nightmare to work with. Architecture tests also become a living documentation, a place where new team members can learn what goes where in an application. This may be a way to save valuable time in code reviews and free up more time to spend on discussions about topics that can't easily be automated. But these are my thoughts and opinions on it all. I really want to hear from you in the comments down below. What spaghetti code disasters have you worked on? Do you think architecture tests could have saved the day or at least made it slightly less painful? Or do you think this is all yet another overhead getting in the way of progress? I do hope you found this video interesting and helpful. I know I've really enjoyed delving into these two libraries. If you're interested in hearing more of my thoughts on architecture and the subject of enforcing it, I was recently on an episode of .NET Rocks where I was discussing modular monoliths. I'll put links to that podcast and everything else I discussed here in the video description below, so be sure to check that out. If you have enjoyed this video, give it a thumbs up and please consider subscribing if you haven't already. But most importantly, remember to leave the spaghetti for your dinner and not your code. Thanks for watching. Bye!